We're going to compare simple and compound interest. So comparing linear and exponential function. Simple interest is interest earned at the end of each year is the percent of the original amount deposited. So the interest you earn in simple interest is same throughout for every year. For example, you deposited $1,000 and you're getting interest $50. First year, second year you'll get $50 again. The interest rate does not change. For compound interest, the interest earned at the end of each year is the percent of account balance at the beginning of each year. So this one, in the compound interest, the interest is changing. What you are adding to your ending balance is changing. The interest rate changes. So simple interest is a linear function, compound interest is an exponential function. Simple interest example, suppose one deposits $1,000 into an account that earns 5%. Simple interest each year. Complete the following table to show one's account balance after each year. So 5% is 5/100. Now we want to know 5% of 1,000. We do times 0.05, which is 50. So you see 0 here, one's balance is he puts in 1,000. So the interest he earns is $50 first year, which is added to his account. It becomes 1,050. Second year, another $50 is added. It becomes 1,100. Now we put another 50 in the third year. So we have 1,100 plus 50. So it's 1,150. Then another 50 becomes 1,200, and then another 50 and so on. Every year it's increasing by 50. Every year you're adding $50. It's addition, so it's a linear function. Plus 50. And it is plus 1. Remember when we did linear pattern? Plus 1. Now if I want to write my equation for this one, it's a linear function. It should be in y equals mx plus b. In y equals mx plus b. So our starting balance, that is our y-intercept. Rate of change is 50. So our equation should be y equals 1,000 plus 50. 50x. That's our equation. Is a plus sign. That's our equation. So in this one, just to generate the formula, here first year you have 1000 and this is 50, so plus 50. Second year you have 1000 plus 50 plus another 50. And third year you have 1000 plus 50 plus 50 plus 50. This equation means this is 1000 plus 1000 times 5/100, the interest rate, times t, or we can say x. In this equation, right, we can say x. This is y and the t is x, the time. Compound interest. Compound interest is an exponential function. Suppose that Ariana deposits 1000 into an account that earns 5% compound interest each year. Complete the following table to show Ariana's account balance after each year. So 0 year she had $1,000. 0 year is $1,000, and then 5% of 1000 is 50. So first year it was added $50. First year adding $50 over here, $50. And then second year you're taking the ending balance over here to multiply here with the interest rate, which is 0.05. The interest rate is 52.5. And when you add it to 1050, you have $1,102.50. Now you are going to take 1102.5 and you are going to multiply it by 0.05. You're going to take 1102.50 and multiply it by 0.05. You have 55.13. So you're going to add 1102.50 plus 55.13, which gives you 1157.63. Now you're going to take 1157.63, going to multiply it by 0.05. You have 57.88. Now you're going to add 1157.63 plus 57.88, which is 1 215.51. Then we're going to use same thing, 1215.51 times 0.05, which is equal to 60.78. Now you are going to add 1215.51 plus 60.78. You have 1276.29. Now how is this pattern changing? Every time you are multiplying by 1.05. Multiplying by 1.05. So if I want to write my equation, since it's an exponential function, y equals a times b to the power x, we know this is our a. We know this is our b. Y is 1000 times 1.05 to the power x. You see the b over here? The b, this is greater than 1. The b is greater than 1. It's a growth. B is greater than 1. It's a growth. Exponential growth. Increasing. The money is increasing. It's not decreasing. To write the formula, there's another way of writing the formula, but you arrive to the same thing. So this one here says it's P naught is 1000 plus this is 1000 times 5 over 100. So it's 50. And then over here, this one says 1000 plus 1000 plus this times 1000 times 1.05. And this one over here says equal to 1000 times 1.05 times 1.05. Over here says 1000 times 1.05, 1.05. So you see, when here is 1, you are multiplying 1.05 one time, and over here, and when it's 2, you're multiplying 2 times. When it's 3, you're multiplying by 3 times. When it's n, or we can say t, you're multiplying by t times. It's t to the power 1.05 to the power t, or n, or x. So if I want to write in using y and x, my equation is y equals 1000 to 1.05 to the power x. This 0.5 is the interest rate, right? The 5%. This part here.